And welcome back to TIA 2014, day 2 of our 3-day conference on the network of the future, again in Dallas, Texas. With us in the Dell TI Now studio is Vish Nandlall. He's the CTO of Ericsson North America. And Vish, welcome back.
Thank you for having me here.
Well, thanks for being here. As you know, the title of this segment is the state of play for software-defined networking. I want to get that state of play from you, but also want to find out about software-defined everything. What is that?
Software-defined everything. Well, you know, when we consider what's happening in the data virtualization space, where we had compute abstractions to give arbitrage of compute resources in a given data center, I think that started the fuse, or lit the fuse, on what you could do from a software-defined instance of something. Mark Andreessen launched, I think, the best qualifying remark about what a software-defined universe is, while really stating that software seems to be eating the world. And I think he was limiting himself to really what was happening within the data center. But what we found since then is that this is primarily a developer phenomenon, where we're trying to make things that are complex more accessible. You know, in the vast pantheon of engineering tools, what we really have at our disposal is abstracting lower layers of complexity and making it very accessible to other people to use and manipulate. So I think when we talk about software-defined everything, it's really following along that general line of let's make this thing that's really, really complex super, super simple. When I started off in the industry, if I wanted to design a new service in the networking world, I'd create a new protocol. And that seems infinitely less efficient than, for instance, creating common structures, abstracting those and reusing them over and over again. And that's really when we start to opening the world of network into something that can be software-defined. We're applying more of a software discipline to network engineering principles. And this is probably going to be the single most revolutionary thing that's going to happen in network across the next 10 years.
Vish, you say there's a couple of different ways and approaches that you can, or different ways you can approach software-defined networking. There's a bottom-up approach and there's a top-down approach. Can you explain that?
Sure. I think, you know, when SDN was first popularized, it was rooted in a technology called OpenFlow, which is effectively a way to manipulate the forwarding tables of data plane within a router. I think this is a limited view. It started off as a very academically driven exercise where we'd like to experiment with new types of routing protocols. When you actually take a look at it from the bottom up, that's the type of equation you get. You get OpenFlow, which effectively provides a protocol between the data plane of a router and the control plane. So you've got this notion of I'm splitting data and control, and I'm creating a protocol instance that allows me to communicate and manipulate it. When you take a look at it from the top down, which is I think probably now the more generalized view of SDN, it's really trying to provide a single API into network resources. So it's not limiting you to OpenFlow. You're actually able to exploit different types of protocols like netconf, like IETF forces, like OpenFlow BGP flow spec. So all these different protocols can manipulate the control plane and the data plane of a router and allow you to do similar things that you can do with OpenFlow. So when I say top down, it's really let's take a look at everything, not just OpenFlow.
Vish, what's the discussion around the integration and reintegration of legacy networking, legacy hardware into software-defined networks? Can you discuss that?
Yeah, I think when we talk about software-defined networks, one of the primary drivers is still the agility that I can get in creating new services. I want to be able to spawn an instance of a firewall, for instance, versus having to plan and deploy a legacy integrated hardware-software appliance, like from F5 or others. If I can actually get into a mode where I can take the flexibility that's driven by really an information model of a physical or a network or a virtual instance and combine it under a common management layer, then I can actually do two things. One is I can really start having that service chaining effect between physical infrastructure and virtual infrastructure. And the second is I can start to compose services much more quickly. Because legacy infrastructure forms the incumbent base, so you can't forget about that. So when I talk about being able to apply abstractions to physical network infrastructure, or the legacy, whatever you want to call it, it means basically having that same control layer control both the physical network and the virtual network. And that gives you the first starting point to to make the transformation towards something that's fully virtual.
Vish, you said at a recent trade show that to compete, the telecom core and network must become service marketplaces. Can you explain that?
You know, it really came out of an observation while I was at Whole Foods Market, and I was walking through the aisles and I was picking out some organic produce that had the name of the farmer underneath it, and I was trying to figure out, why is this such an enjoyable exercise? Why do I have a smile on my face when I'm at a marketplace, but at the end of the month when I get my utility bill or my phone bill, I'm in such a dissatisfied mood? Why is that experience not as unique and fulfilling as the experience of going to produce marketplace? And the reality is that things aren't unbundled in a utility or a telco world. Everything is delivered as monolithic services. So this process of doing service abstraction and allowing a consumer to kind of consume individual network services on demand, whether it's a CDN, whether it's a VPN, and not have that take 4 to 6 months to implement. That's the revolution that needs to happen. It's a revolution of making that network look less opaque and more transparent, and visibility into all the services of a network, so that it becomes a marketplace that I can select and choose which ones I want, much like I do at Whole Foods.
So how do you, if you could go into a little more depth, how do you manage economies of scale as more developers use the network as a marketplace?
So there's a tremendous amount of technologies at the heart of the carrier core that needs to change. Currently, things are fairly monolithic. It's all scale-up structures that are very stateful. In terms of being able to compete at an order of magnitude reduction in compute costs and in storage costs, we need a different type of architecture, something that's more web scale in nature, that's stateless, that has load balancing front ends. And if you actually take it to its natural conclusion, you end up seeing something that looks very like what the hyperscale players such as Google and Amazon are using in their data center core versus the scale-up Cadillac servers that you see in a telco environment.
Vish, you said, and I'll finish this panel or this discussion with this quote that you said again at a previous trade show: "The guy that has the biggest developer community is the guy who wins." Can you explain that to us?
I think we're rapidly moving into this platform era, and we're seeing services consumed not directly, but indirectly in many cases. For instance, instead of buying a voice service directly from a service provider, I'm actually consuming voices through indirect channels, like in my gaming platform. Potentially I'm using it to set up a conference call in the middle of a Halo session. So we're seeing voice services not being consumed directly, but indirectly. And when it starts going to these indirect channels, the community that's actually creating the go-to-market for you are the application developers. And so when you move to that platform, you're consuming things indirectly. The way you actually create scale and amplify really the go-to-market of your particular service, in this case, let's call it voice, is through a developer community. I think it's very short-sighted to go and look at a technology like, let's say, WebRTC and say, that's a business. Because a business really needs those technology foundations, but it needs a developer ecosystem, it needs a mean to monetize, it needs retailing, it needs distribution. So until we frame those other technologies, other dimensions of a technology, we don't have a business model. And the pivot point for when something becomes at scale useful is the number of people that are on it. It's driven by network effects. You know, the more people that are using a particular thing, the more useful and valuable it becomes. And so developer economics as applied to these technologies is the things that drive it. That's why we're seeing a lot of open source software start to compete for eyeballs, whether it's Open Daylight, trying to get enough developers on their API definition for their SDN controller, or whether it's in something like OpenStack, trying to get enough developers using their user experience interfaces to develop and deploy virtual instances of applications. These things are all driven by who has the biggest developer community. That's how you're going to settle the Betamax to VHS debates across all the different ways of implementing these software-defined anythings.
Vish, I know in a little while later today you'll be giving a keynote presentation. For our viewers who don't have the pleasure of watching that, can you give us a quick summary of what that's about?
I'm going to be talking about what the 2020 network is going to look like. And I think as we take a look at these technology evolutions, we're going to see some pretty material disruptions, both in terms of business model, how the industry competes. We're moving from an era where we've competed at scale and robustness of very few network services, voice, messaging, data access. And we're moving to something where it's much more about competition at scale across many, many different applications. And it's driven by the model of these application stores, whether it's through the Android community or through the Apple community. I think as you move in that direction, you start to need to rethink how your network is. How many different sessions are the ways I'm delivering video across my network, and media, which is the ever more popular component of internet traffic. Are we setting up the types of capabilities that are required to deliver that? Do we have at the very edge of the network, from a wireless perspective, something that is truly ubiquitous, that handles all different types of workloads? And I think as we look at those, we start to see different ways of building the network. What will 5G be? How do I transform from fixed distributed networks that are running protocols like BGP and OSPF towards something that's more software defined? How do I take the core of my network and move from things that are scale up to scale out?
Vish, I'm looking forward to hearing that presentation, but we appreciate you taking the time out of your day to be with us. Thanks.
Thank you.
Thanks a lot. And thanks for joining us for our coverage of TIA's Network of the Future conference. The Dell TI Now studio will be streaming live throughout the conference. You can view our live stream and all of our programming at tinow.org. So long.